the homework exercises tonight on page 562, 1 through 20 odd, page 529, 59 through 64 all, 545, 38 to 46, and 550, 51, 52, 57, and 58. When we talk about growth and decay, there are a number of different formulas. There are two formulas for growth. The first formula is y is equal to a times 1 plus r raised to the t. And the second formula is y is equal to a e k t. The important part is to understand which each one of these variables represents. Y is equal to the ending amount in this first formula. A is equal to the beginning amount. R is equal to the rate, which we need to change to a decimal, and T is the time. The formula for decay is the same formula, y is equal to a times 1, but it's minus r raised to the t. So you still have the same variables. The only difference is this is a minus sign, which represents decay. In the second equation for growth, we have y is equal to a e k t. A is the the beginning amount. Y is the ending amount. K is a constant. K is a constant. And T is time. As far as decay is concerned with this formula, it is y is equal to a e negative kt. So we have a negative k as opposed to a positive k. Formula or word problem I have up here says a cup of coffee contains 135 milligrams of caffeine. If the caffeine is eliminated from the body at a rate of 11% per hour, how long will it take for half of the caffeine to be eliminated from a person's body? So the formula we're going to use is y is equal to a times 1 minus r raised to the t. It is eliminated, so we know it's about decay. It says rate of 12 per hour. So A is equal to the amount. R rate. We're looking for how long it would take, so we're looking for time, over time. Y 65. It says half of the caffeine to be eliminated. That's why it's 65. So put those numbers in our formula. So we have 65 is equal to 131 minus the rate. We're changing it to a decimal, so decimal 11 raised to the 2. Now I would like to go back and look at the equations we just looked at. On these particular formulas, on the first formula, we have y is equal to a times 1 plus r raised to the 2. There are no e's in the formula. But on the second equation, you see where you have y is equal to ae raised to the k2. There's an e in the formula. If there's an e in the formula, you have to use LN. But if there's not, you don't have to use LN. But you can. I say this because you'll find that I will almost always use LN even if I could use a log. I could use log base 10 here, but I might as well just use LN. I'm going to get the same answer. Divide everything by 130 to end with, you get 1/2 is equal to 1 minus decimal 11 raised to the 2. Like I said, if you want to use log base 10, you're certainly welcome to. You should get the same answer. Or you can use LN. Like I said, I usually use LN because I have to when it has an A in the formula, and I can when it doesn't. So I have LN of 1/2 is equal to LN of decimal 89 raised to the 2. I move t to the front of the logarithm. I get t is equal to ln of decimal 89. Then I'll divide ln of 1/2 by ln of decimal 89 to get my answer. Plug this in our calculator. We have ln of 1 divided by 2, close parentheses, divided by ln of decimal 89, close parentheses. And you get 5.9480. You will get that same answer if you use log base 10. So it takes 5.9480 hours Any question about that? K is a constant. K is the same for carbon 14. It is a different number for uranium. When we talk about population increases at a faster rate in different places of the world. And there are a number of things that have an effect on population. For instance, the bald eagle population was endangered years ago, and so they were put on the endangered species list. There were a number of reserves put together for the bald eagles. Well, those reserves protect the bald eagles. They have no predators, no hunters, no lions or things that eat the bald eagles. They have veterinarians who look after the bald eagles, and they have extra food and water so the population will grow. The same occurs throughout the world. There are a number of different things that have an effect on a population. Anybody want to give me some of those things? Okay. The weather. If there's a drought, that could have an effect on the population. Gabby? Water supply, that would have to do with drought. Food supply, disease, health care, war, religion, actually. There are all kinds of things that have an effect on population. So in every different location, there's a different constant K for population growth. For instance, that number in Raleigh-Durham, that K, may be different than Mobile, Alabama, because of the research triangle in Raleigh-Durham. There are more people that want to live there. So what I'm saying is that constant K changes based on what type of problem you're working with. So the constant K for carbon-14 remains the same always. So this problem asks you to find that information. It says the half-life of a radioactive substance is the time it takes for the half of the atoms of the substance to become disintegrated. All life on Earth contains the radioactive element carbon-14, which decays continuously at a fixed rate. The half-life of carbon-14 is 5,760 years. That is, every 5,760 years, half of the mass of carbon decays away. So the problem asks you to calculate that. So we're going to take our formula, y is equal to a negative k2. About the k, it's a negative number. And we're going to calculate that. So half-life means you start with 2, and what do you have left over? 1. Okay? So if we start with 2, okay, what is the time? The time is 5,760 years. The heating amount is 1. Because it's half of what was there, similar to the caffeine, right? Put all this in. That 1 half is equal to e raised to the negative 5760 K. Because there's an e in this formula, we have to use LN. So I have Ln of 1 half is equal to Ln of e raised to the negative 5760 K. If I move negative 5760 K to the front of the logarithm, I have this. So what is Ln of e equal to? It is equal to 1. So now I have Ln of 1 half divided by negative 5760 is equal to K. When you put this in your calculator, you get Ln of decimal 5 close to 26 divided by negative 5760. And you see where you get that is in scientific notation. So K is equal to decimal 0.00012. That is the constant for carbon-14. So the next problem says, or the rest of the problem says, paleontologists examining the bones of a woolly mammoth it estimates that they contain 3% as much carbon-14 as they would have contained when the animal was alive. How long ago did the mammoth die? So we're back to the equation. Y negative K2. Well, A, like I said, was the beginning amount. Well, because we just finished finding out what carbon-14, the K was, and so we're using the same formula because it's just the B part of the problem. K we found to be decimal 0.0012. T is what you're looking for, and Y is the heating amount. then we have negative decimal 0.00122. Y over A is what remains. So what remains? 3%. So we have decimal 0.03 is equal to B negative decimal 0.00122. That's Y over A is what remains. 3% is what remains. So we have ln of decimal 0.03 is equal to ln of B negative decimal 0.00122. So I have ln of decimal 0.03 is equal to negative decimal 0.00122 ln of B. What did we say ln of B was equal to? 1. So what am I going to divide by? I'll divide by negative decimal 0.00122. To solve for T. When we plug this in your calculator, we come up with 29,221.3158 years. Compound interest, like I said, we had one of these last week, but this formula is slightly different. Once again, I will give you the formula in the problem so that you're not trying to figure out which formula to use, nor do you have to memorize all the different formulas. So on this particular formula, I have A is equal to P times 1 plus R over N raised to the NC. P is equal to the principal amount. That's what you're investing. R is equal to the rate. It is a percentage that you need to change to a decimal. N is the number of times a year. It says right here is N. T is the time. And A is the ending amount. So it says Marta has $100 to invest in a savings account. That's the amount she's investing, $100. Earning 6%, that is the rate. You need to change to a decimal. Compounding quarterly. Compounding quarterly means 4 times a year. The time is what we're looking for. We don't know that. The ending amount is $1,205. So we want to take all that information and plug it in our formula. So we have $10,205, the ending amount, $100 for the principal. At the rate, decimal 0 to 6. The number of times a year is 4. And we have 4 times the time. The first thing I would do is divide by 100. calculate this selenium. Once again, you can use LN or you can use log base 10. I would probably just use LN because I just do that for everything. So I have LN of 12.05 is equal to LN of 1 plus decimal 06 divided by 4 raised to 14. Everybody still okay? Alright. You need to move 4 to the front of the logarithm. So I have LN of 12.05 is equal to 4t times LN of 1 plus decimal 06 divided by 4. So then I would divide. I have LN 12.05 close the parentheses divided by LN of 1 plus parentheses decimal 06 divided by 4. Those both sets of parentheses. And I get 167.1791, but what do I have to divide it by? 4. If I divide that by 4, I get 41.7948 years. That seems like a very long